Let's see an example of the Archimedean property. In this example, we're going to show that the supremum of the set A is 1, where the set A contains the element of this form, or the elements of the form 1 minus 1 over n, where n is a natural number. If we plot the elements of the set A, we see 0 there, and we see 0 here, and a 1/2 here. Similarly, 2/3, 3/4, 4/5, and so on. However, it is not clear whether we get 1 in this set. We will prove that 1 is not in the set A. Since for all n, we have negative 1 over n is smaller than 0, which is strictly smaller than 0. Then we can add 1 to both sides of this inequality. And this gives 1 minus 1 over n in the left-hand side and 1 in the right-hand side. This shows that the quantity 1 minus 1 over n is strictly smaller than 1 for all value of n. Hence, 1 is an upper bound of A. Now we want to show that 1 is in fact the supremum of A, the least upper bound of A. To prove that 1 is the supremum, we will assume a number beta which is larger than 0 but smaller than 1, and it would be sufficient to prove that beta is not an upper bound of A. So 1 is an upper bound of A, and no number smaller than 1 is an upper bound of the set A. That would prove 1 is the least upper bound, hence the supremum. Since the quantity 1 minus beta is larger than 0, means positive, by the Archimedean property, there exists a natural number n such that n times 1 minus beta is larger than 1. Here, we are considering the quantity 1 minus beta as an x and the quantity 1 as in y, as in the Archimedean property. Now, dividing this inequality by n, we obtain this inequality. 1 minus beta is larger than 1 over n. Now, transposing the quantity beta to the right-hand side and the quantity 1 over n to the left-hand side of this inequality, we obtain the following inequality. Now, since the quantity 1 minus 1 over n is in the set A, which is larger than beta, so beta is not an upper bound. This proves that the supremum of A equals the number 1.